Hello, everyone, and welcome to our virtual road trip webinar series. I'm Molly Berry with ATS, and it's my pleasure to welcome you on board today. If you've joined us for our last trip, you'll remember we went behind the scenes of an asphalt plant and an asphalt paver to learn how asphalt is made and how it's paved. So now that you're back and learned the basics, we're going to teach you the 7 habits that asphalt producers and pavers use to ensure a successful operation. Before I introduce our experts, please turn your attention to the attendee controls at the bottom of your screen. I know we are all Zoom experts by now, but just a reminder, if you'd like to join the conversation later, you can raise your hand and I'll unmute you and you can address our panelists directly. At any time, you can answer or enter your questions and comments into the Q&A box. Today's co-pilots are TJ Young and Steve McReynolds. TJ Young has been working in the asphalt industry for 40 years, working with plant manufacturers, material producers, and as a consultant. He is currently the production manager for Duval Asphalt while maintaining his consulting and training schedule. Steve McReynolds is the director of operations here at ATS, and he brings over 20 years experience in the industry, 15 of those years with the Florida DOT. Steve is also contracted by Duval Asphalt as its QC manager. And again, I'm Molly. I'll be your tour guide today, and I'll address any questions you might have at the conclusion of our trip. So I assume your luggage is stowed and your seatbelts are fastened. So TJ, I think we're ready to depart.
It's a pleasure to be with you guys here today. First thing we're going to talk about is 7 habits of highly effective producers. Now, it's important caveat to this presentation. These are not my ideas. These are ideas that I discovered as I worked for about 20 years doing consulting work for producers like you. And I discovered a trend that people that were having great success in their mix operations followed certain procedures. Those procedures over time become so ingrained into their operation that they become habits. And this enumerates these habits. So these are not necessarily my ideas, and I think I'm speaking for Steve as well when he gets to the paving operation. These are things that we have observed over time that producers who have great success, this is the way they approach their operation. So let's take a look. Once I figure out what to do, let's take a look at our plant process and let's talk about what some of these really effective procedures are and these habits are. The first thing is producers that have a great deal of success, they know what's in their stockpiles. Now, this may seem somewhat basic, but you know that when you constructed your job mix formula, you used average gradations for each of the individual aggregates for those stockpiles. And there's no guarantee over time that those gradations of those individual materials are actually exactly the same as what was established in the JMF. Now, we're all allowed to adjust our mixes in small percentage points to account for this. But the point here is that things do happen at the quarry. Screens get changed in the operation and gradations get a little bit finer. As screens wear, gradations get a little coarser. If there's any upset conditions at the quarry or at the transfer station, we bring a lot of the aggregates in Florida by rail because we're basically out of stone in the state. So you've got a transfer point at a rail terminal. You've got a transfer point with trucks bringing it into your yard. And the point is here that things can happen. And the caveat here is that gradations will vary. Okay, so they are going to change. The question is, how much do they really do that? So checking your gradations as they come into your yard is an excellent best practice. Most people will check this anywhere from 1 to 5,000 tons. I mean, I'm a big proponent for checking every 1,000 tons of material that comes into the yard and knowing what those gradations are. If you look at this little blackboard here, this is actually a diagram of the stockpiles in the yard. And you'll notice some key numbers on these screens and little diagrams of the date the material came in and what the percent passing was. This plant uses percent passing. Percent passing was in the control sieve for those individual stockpiles. So the point is that producers that have success, they know what's in those stockpiles before they put them in the plant. And because we're going to be testing on that, then your first in, first out inventory method is better than your last in, first out approach. Last in, first out is really easy. Throw the rock in the front of the pile, feed it into the plant. First in, first out allows you to check your new material and still use your older material in your plant process. So you're always staying on top of that. And for that reason, a good idea is to separate material into cells. So you have like front, back, or a left or right. And then you use that cell, you know what's in that material, and you recharge that material a cell at a time. So this, again, shows a picture of the yard, and you can see this is using a front-back approach. In fact, you can see a piece of equipment over here on the right of the screen between a couple different shipments that came in the yard. And again, this shows the map of the material and some data points that show, what the control sieves are. If you look at the right-hand side there, it shows that on 10/15, there was a pile brought in with a control on the 3/8 of 54 passing. 3 days later, we had another cell come in. It was 59 passing on the 3/8 for that particular material. So these people are on top of what's in their yard. And then if there is a change, you can use blend sheets to adjust your bin pulls at the plant. And then the question really becomes, are you going to do that proactively, or are you going to do that reactively? You can do this proactively if you see a large adjustment. You use these kind of blend sheets to create your job mix formula or your bin pulls anyway, or your percentages that you're going to run your plant at based on average gradations. And so you'll come to the day when you look at this and say, wow, the material's really fined up, it's really coursed up, we're out of the other material. Maybe we'll make a proactive change. And the difference between producers that are totally on top of their game and always ring the bell with bonus or never have any problems is they've embraced this proactive concept, and you're going to see that throughout my presentation. So again, not our ideas necessarily. This is what we see working with companies that have great success. They know what's in the pile. They're making a decision proactively on whether they're going to make a change or not. They're not going to wait for the mix to go bad. For that reason, they also go and check their plant calibrations, because the point is calibrations do shift, and they are going to shift, and the plants are not going to be perfect. It's routinely checking plant calibrations, which is not changing. So checking is not changing. That's a key point here. Let you know that your calibration has not shifted. Usually this is a mechanical problem or electrical problem that caused this to be the case. One of the common problems that happens with a plant is they'll have a plug feeder, and the guys will open the gate to remove the obstruction, and they'll accidentally put the gate nut back in exactly the same position. This happens a lot. And this, of course, changes your calibration and will affect the final mix. So checking your calibrations proactively is what people do that have great success, and not waiting till the mix just goes bad. Like I said, electrical and mechanical problems are usually at the fault of this, and it's not necessarily a human problem. It only takes 30 or 45 minutes per test. And what a lot of guys will do is check those calibrations at the end of the day when they're on hold, and they'll just check a feeder, or they'll check a belt scale, or check an asphalt meter. It's important, if you do find a shift, that you don't make a change without contacting the quality control department, because they may have adjusted the bin pulls to make up for this calibration error that they didn't really know existed in the plant. So when you finger a calibration shift, you want to work with QC and say, look, this is what I've found. It's going to be a little coarser, a little finer than we anticipate. What do you want us to do here? And then everybody's working as a team. Teamwork is something that is going to be woven through my presentation and Steve's presentation. And I guess this should be another bullet point, because people that have great success have developed a good teamwork protocol inside their organization. Okay. And again, the point here is proactively verifying that your calibrations are okay rather than get caught with your pants down. Picture of the calibration screen, picture of a truck parked, checking calibration. Producing long runs. These don't bounce between mixes rapidly. These drum mixer type plants take time to level out. This is affected by the PID loops in the system. Since it takes a little bit of time to level out, and because these plants are really not designed to make short runs of many different materials, they're really designed to make long runs of one material. You want to really consider staggering your start times on different mixes with your paving crew so that you can produce a good quantity of material and give the plant time to level out. Try producing a silo at a time. What I like to embrace is this idea that your absolute minimum per run would be 100 tons. So 100 tons of one mix, make a mix change, make 100 tons of another mix, make a mix change. If you stagger your start times, this allows you to come in early, produce an entire silo of mix, start shipping that mix while you're shifting to a new mix, filling another silo. The next crew comes in, say a half hour later, an hour later, starts paving on that job. And now you're draining that mix. And after that silo is full, you can switch back to your first silo and recharge that silo. And you can make a good quantity of material at a time. A lot of people are not familiar with this idea of a PID loop in the automation. And basically what that is if it needs to make a change, how fast does it make that change? Does it increment? How much time does it take to close that loop? Most plant automation actually starts up on theoretical values before the sensors start kicking in. So there's another time delay there. And this is why you'll discover that some plants take a little more time to level out than others, because the PID loops are not set real tightly. Usually the manufacturer is the only one that has access to this information. You can work with your control vendor and improve that, but this is a fact of the business. And once you understand that exists, then this whole idea of producing in long runs makes a lot of sense. Also, producing steady runs. You don't want to jack your production rate up and down rapidly. Okay, again, it takes time for the controls to adjust for that ton per hour change. And the PID loop is going to affect that. That makes some sense, right? To someone who's plugged into this new reality. The other thing that's very critical is it takes time for the baghouse fines to catch up. So it can take anywhere from 20 to 40 minutes, really at the extreme, but it can take as much as 20 minutes for the baghouse fines to be collected, go on the bags, sit on the bags, get cleaned off the bags, be dropped in the hopper, be discharged in the hopper, go down the hopper, go up to the incline conveyor, and go back into the plant. So if you change your production rate rapidly up and down, there's a chance that your baghouse fines are always going to be a little bit out of sync. This is why most of the people that are training people on how to run plants is to make incremental changes in production rate, like 20 ton an hour. every 5 minutes or something like that, because that allows your fines, which are very important to managing voids in the final mix, to be in the proper range. Steady running produces steady mixes. So there's your soundbite for the day. Steady running produces steady mixes. That's most people that have great success are doing that. Also control the mix temperature within 10 degrees. Now you're going to say 10 degrees. You lay $100 bill. You lay $100 bill on a control counter and tell that operator to control that temperature within 10 degrees. Get on the radio and tell that loader guy to always feed from the same place at the pile. Don't change the depth that he feeds from, because wet material is going to be on the very bottom of the pile. And if they can do that all day, they can take that $100 bill home. I guarantee you, you'll lose $100 every single day. So our master temperature range could be 20 to 30 degrees. But you're going to find when you talk to paving experts and compaction experts that if you move that paving temperature more than 15 degrees, it's going to change your optimum rolling pattern. And because voids and field density are so critical to the success of our mixes, we must do a good effort at controlling the temperature within 10 or 15 degrees back at the plant, and be knowledgeable of the fact that the temperature coming out of the mixer is not necessarily going to be the same temperature that's in the truck, particularly when you get to big rock mixes, because it takes time for the inner mass of those large stone particles to stabilize in temperature. And while they're doing that, they're robbing temperature from the surface. So I call this managing chute to truck temperature. And you'll find with some mixes, high wrap mixes, big rock mixes, SMA mixes, open graded friction course mixes, that you're going to lose, say, 20 degrees from chute to truck. So you learn to manage that, and you try to make sure that you're controlling that temperature within 10 or 15 degrees. I always shoot for 10, okay? Because again, this affects the rolling pattern, which is what Steve's going to be talking about next. And so simply holding mixed temperature consistent, which is doable, helps achieve consistent density in the field. And producers with great success on the paving side and the production side do this. Next thing is to socket load your trucks. You want to load in multiple drops. I call it socket loading the truck, basically by loading in 3 drops, front, back, and middle, which is a standard practice in this industry for a square body truck. This minimizes the chance for segregation in the vessel, the truck vessel, and minimizes and controls the rollout, because you're loading against the bulkhead in the front, you're loading against the bulkhead, so to speak, in the back, and then you can socket load that last drop right into the middle of the truck. Now, if you're running a live bottom truck or you're using a bottom dump truck, then you want to test your mixes. Here's a concept for you. For a lot of people, this is kind of an arguable point. Like a lot of people say, well, we load all in one drop, we creep and go, we have a live body truck, we haven't got a problem. My suggestion to you is you think about proving it to yourself, okay? Socket load your trucks, front, back, and middle. Check every other load for gradation consistency, and then use your procedure and check every other load, and scientifically look at the data and see if you get some variability here. I've found in my experience consulting around the plant that the test consistency and the mix trends can frequently be improved with properly loading trucks. And it's always a point of argument, but I've demonstrated it time and time again, even for mixes as small as 1/2-inch mixes. Particularly when you get in 3/4, 19 millimeter mixes, or 1-inch, 25 millimeter mixes. If you track you do a lot of testing, you'll find that your gradation consistency will improve by properly loading trucks. So it's a point of contention, a point of debate, but people who have mixed success, producers that have mixed success, employ this habit. And so now you're arguing with your competitors who are having great success. And so the point is that if you have any disbelief on this, it can be tested working with your QC department. Also, it's very important that you don't load a cheddar loaded truck. What that means is at the very end of the drop, most control systems will say, oh, I got to put another 500, 600, 700 pounds on that truck. They put 100 tons on, close the gate, 100 tons on, close the gate, 100 ton close the gate, get close to target, and then shoot the buzzer off, send the truck to the job site. Our test procedures when we're testing out of a truck body are to dig down 12 inches, which should eliminate this phenomenon of having a little bit of surface segregation. But by not sending cheddar load trucks to the test rack, you're absolutely ensuring yourself that if the guy at the test track has had a bad day, or if he has a bad back, or if he's hurting, you're not setting up a situation where he might accidentally sample too many large stones or fine material in the test. So these are procedures for loading trucks. Last thing is make calculated mix changes. Wait and look for a trend. Don't make rapid changes based on one test result because things can happen. The life is not perfect. And so wait and get 2 or 3 samples, look for the trend. And if it trends in one direction, go ahead and make a mix change. So those are the 7 habits of producers that really have great mix success. They know what's in their piles. They keep their plant calibrated. They check their calibrations proactively. They produce in long runs. They produce in steady runs. They control their temperature within 10 degrees. They load trucks properly and they make calculated mix changes. So if I can figure out how to do this properly, I'm going to go down here and escape, and I'm going to stop sharing. And Steve, it's yours.
All right, well, thanks, TJ. Let me get set up here. Start the paving side of it. All right, so I think we're showing our program here. Give me a little nod there, TJ, if you can see it like it's supposed to be seen. Thank you. Appreciate it. So the 7 habits of highly effective pavers. Certainly this is not everything that occurs on a paving train day in and day out. We found that if you follow these 7 habits, that you'll greatly improve your chances of a successful paving operation. So we keep doing these day in, day out, and they become habits, just like we're talking about, then your success is going to get better. So these 7 habits are: a lead tailgate meeting, be mindful of tack application, manage haul trucks, monitor the hopper and screed, produce a quality mat, master the roller, and prioritize quality control. So this lead tailgate meeting, this is should be held by the lead QC and the paving foreman. And there's some key items on this tailgate meeting. So we have the whole paving crew around and maybe the superintendent, and we're going to discuss what we're doing. So some of the types are some of the things that we're going to discuss is the mix type that we're placing, the lanes that we're going to be paving, what number lift are we on? Are we on the first lift, second lift, third lift? Are we doing multiple lifts? The thickness we're trying to achieve of this lift. Of course, we want to discuss the slope, our density target, the type of compaction equipment we're using. You're going to bring this subject up. Do we feel confident that we can achieve density of what we're placing with the rolling equipment that's been provided for us for the day? And also the rolling pattern. And those are just some of the highlights of this tailgate discussion to lead off the day. And we also require our QC technician to email this back to management, either at the beginning of the shift or at the end of the shift. So we got a permanent record that the tailgate discussion occurred and that, we were all on the same page and we're well on our way to a successful paving day. Secondly, we need to be mindful of our tack application. We want to ensure the surface to be tacked is dry and has been swept clean. Tractor brooms, vacuum trucks, and power blowers all work really well, but we want to make sure that we get that surface to be tacked clean. We don't want to spread that tack over any kind of heavy dirt, dust, something that might cause a bonding issue. Also on the truck, we just want to make sure these tack bar tips are spraying properly for full coverage. We don't want any cornrows or wide gaps. We want a nice coverage of the entire surface to be paved on. Want to make sure the proper application rate is used. And this is usually a QC function. He gets with a tack distributor operator and make sure that they're putting the right application for the right surface that we're tacking on. Also, if you're using an emulsion, you want to make sure that the tack is broken before the pavement begins. It's always a good idea to make sure that tack breaks. That way we know we're going to get a good bond. Make sure not to over tack in hand wand areas. So if we're spraying that beginning joint or some side joints that need a hand wand attention, we want to make sure we don't over tack. So, we have a big delay in waiting for that tack to break, or that we get so much down that it, pumps up through the mat. And remember, proper tack application can help with density. So if we get this right, it's really going to help with our density. We want to manage our haul trucks. We want to balance the trucks with production. Now there's software out there that's available, for example, like the CAT production calculator app. But this is very important. We want to, just like TJ talked about the plant, a steady production run, we want to be steady with our paving. We want to continue the best we can going down the road without interruption and without stopping. Now we know that's not always feasible. Wish it were, but if we get enough trucks balanced with the plant production, the distance of the haul, and to ensure that the minimal stops that we can throughout the day, it's going to greatly improve our chances of a nice, smooth, densified paving mat. We don't want to bump the paver or the MTV if you're using one, but if we back that haul truck into the paver, chances are we're going to create a knot in that mat that we're either going to have to roll out or we're going to have to replace if it's a final surface course because of a straight edge deficiency or a laser profilograph deficiency. So we want to make sure that the paver or the MTV picks up the truck and the truck does not back into the paver. And we also want to make sure that we charge the hopper swiftly. When that paver picks up the truck, they want to raise that bed with the tailgate locked, get it nice and elevated, and then unlock the tailgate and swiftly charge the hopper. We want the mix to come out in a single mass the best that we can. We don't want to dribble any of the mix out. You're going to possibly segregate the mix if we do that. Monitor the hopper and the screed. So we want to maintain the hopper at 1/3 to 2/3 full at all times. The picture on the left is not a good example of how the hopper should look while we're paving. The one on the right certainly is a lot better. We want to fold these wings periodically to keep the mix live, but we don't want to fold those wings with the hopper looking like it is on the left-hand side of your screen there, or the left-hand picture. If we do that, we could roll some colder segregated material from the outside of the hopper directly down on those conveyor slats, and then that's going to end up right into the screed and show up as segregation in our mat. So we certainly don't want that. We want to keep that hopper 1/3 to 2/3 full at all times. We want to check the depth frequently. If we're changing depth, we want to use the screws on the back of the screed or the toe points for both sides. So you don't want to use the screws on one side and the toe points on the other. They may not be equal in raising or lowering the screed to where it needs to be. And it also can cause a warp in the screed. And we know that if we get a warped screed, we're not going to pave a smooth, aesthetically looking mat. We're going to have issues. So we want to use either the toe points or the screws, not one or the other. Monitor for marks and drags. We always want to be looking behind that screed and make sure that we don't have any marks the screed's making or any drag, something caught in the mix, come out of a haul truck or something like that, and is dragging that mat, going to cause us a big problem. The sooner we catch that and stop and repair it, the better off we are. We also want to maintain a constant head of material in the auger. This is important for thickness, for smoothness, and also to eliminate that segregation potential. We want to produce a quality mat. We want to avoid excess looting or raking. Now, naturally, this is a handwork area and you're going to have some looting and raking, but we really need to pay attention to cut that down the best that we can. Plan our paving mat the best we can to avoid these. We don't want to backscatter material. So we have something in the mat that needs to come out. We just take our lute, the end of it, pull it out, and then take a shovel full of hot mix, go put it in the hole that you extracted the problem from, and then lute it over. And as we lute, it has a tendency for the larger stone to come to the top of the mat. We want to make sure that after we lute and get it to the right elevation, we want to get those larger aggregates out of there. We want to rake them off the mat and cast them to the side, do away with them. We don't want to roll it in the mat. Could cause issues down the road with raveling, and it just doesn't look good as well. So we don't want to roll those large rocks in there. We want to get rid of them. We want to master the roller. Ensure your pattern is keeping pace with the paver. If it's not, insist the paver speed be slowed down. So we do not want that paver getting way away from our rollers. We're back here trying to achieve density and get a nice smooth mat. And we need, to be compacting that mat at a good temperature. If our paver gets too far ahead, we could lose temperature in that mat. We might not achieve our density. So really the rollers need to take precedence here. Density needs to take precedence, and let's slow that paver down if it gets too far ahead. We need to monitor the mat for pickup. If the roller picks up something, nothing worse than we get a pickup on that roller, nobody notices it, and we go 1,500 or 2,000 feet down the mat with the roller picking up material and making holes in the mat. It's going to make for some pretty ugly repair, and it could cause issues down the road. We also want to use a proper technique of our rollers as we stop to change directions to prevent roller heads. We want to come in at that nice angle instead of straight forward and backward, and then reverse our direction to avoid those roller heads. We want to prioritize our quality control. We want to monitor our edge lines for straightness. That's a pride thing for me. It's I think we can pave in straight lines, and we just need to pave in straight lines. It looks a lot better. It means we're paying attention to what we're doing. We want to monitor the temperatures of incoming trucks and the mat. You remember TJ had said that the temperature directly goes with density. Now out on the road, we can't control the temperature like they can back at the plant. So we have to monitor that temperature, so we know if we get a drop in temperature, we can notify the plant and possibly change our rolling pattern. Or if we get a spike in temperature, same thing. We need to call back to the plant, say, hey, the last 3 or 4 trucks have been really hot or really cool, and we need to get this temperature corrected. so we can get good density out there. Want to monitor our spread rate frequently. I know in Florida here, we have a specification that we do the first 5 loads or 100 tons and then try to do it every 200 tons after that. I think a good idea is monitor that spread rate every 100 tons to make sure we're getting the right depth mat placed. Also, for quality control, we want to constantly look at that mat, look for defects such as pulls or tears or any segregation, so we can quickly get those corrected. We want to obtain process control course and ensure our rolling pattern is achieving density. We want to adjust this rolling pattern if needed based on these PC cores or our density gauges. It's really important. Remember, density is everything. So we really want to monitor that. Also, we want to check all our joints in the mat for smoothness with a manual or rolling straight edge. Usually if we're getting good density, we know we're going to have a good smooth mat, but we need to check those, especially at those joints. Some of our tools for doing those are temperature guns. That's the infrared temperature gun up in the right to monitor our mat temperature. And then also our density gauges, either nuclear or non-nuclear, work really well as long as they're calibrated to the mix. They work really well monitoring our density. So successful paving needs total buy-in from everyone. Everyone meaning from upper management all the way through the organization. We need to praise loudly when deserved and provide constructive correction when needed. So thank you. And I think we're going to move to Molly. If I can unshare my screen here. We good? There we go.
We're good. Okay, thank you guys so much. Definitely good habits to adopt when you're at the plant or out on the roadway. We have a couple questions for you guys. TJ, we'll start with you. Going back to the beginning of your presentation, one of the habits to adopt is to monitor your stockpiles. And you talked about the first in, first out, or the last in, first out strategies. Can you elaborate on that first in, first out? Is that meaning when the aggregates were initially delivered and placed in the stockpiles? And how do you communicate where in the stockpile to go to your loader man?
Yeah, first thing, communicate with the loader man, very critical. Every day we should be reminding him or telling him, where we're going to dig from. LIFO and FIFO is sort of a business term. Basically what we're really talking about here is use aggregate that you've already tested and conforms to what you're looking for, right? Use stockpile where what's in that stockpile. You verified that's close to the JMF, and not use aggregate that comes in right in from the yard. A lot of times you'll find a problem. You go to a site and they're having a problem with the mix. They have just one stockpile and the trucks are delivering aggregate and they're feeding it right into the plant because they're in the front of the face. So I've changed a lot of guys' operations up by having a left side to the pile and a right side to the pile, right? And you test the left side. First, the material that came in before the latest, what's in there, use that material. And as you're recharging the right side of the pile, you're able to test it. Or you can do a front and back kind of thing. And most stockpiles can be reorganized to make that demarcation, if you will. That's pretty much all we're really talking about here. Feeding material that you know what it is into the plant, and hopefully it matches pretty closely what the gradations were when you designed the mix.
Okay, good. And a follow-up question to that, when building the stockpile, what is the best way to prevent segregation?
Wow, that's a whole training program. It's right. most stockpiles, I'll just, we can come back and we can do a whole thing on stockpile management later. Molly, maybe we want to do that because
That
there's a
might
lot
even
of,
be listed on the website. Yes.
yeah, there's a lot of different ways to build a stockpile. And each one of those has got its own best practices. Most plants are feed from material that's been placed by truck. I'd say maybe 80 to 90%, at least 80%. Have material being delivered by truck. And so pushing them up, we call it pushing it up, but just pushing that up into a wall, into a mass, and not driving on the material excessively, which can promote breakdown, and lifting it with a loader too high, which can promote segregation on the outside edges, as it comes down. Just moving it into the mass of the face and not massaging it too much, not driving on it. And if you're worried about some load to load segregation problems, which can occur, a nice handy thing to do is take a track hoe and bring that material up and make it higher. And that gives you an opportunity to blend. And then as you extract, you want to try to extract across the entire face. So the loader guy should not just dig in one spot, kind of work the face. I mean, that's the way most stockpiles are managed at most plants. We can certainly set up some personal conversation with somebody if they want. We can go through all the other kinds of stockpiling techniques, radial stackers, tunnel feed systems, bunkers, even aggregate silos. They each have their own kind of best practices on how to manage.
Okay, great. And then yes, maybe stay tuned. Stockpile management best practices is indeed a future webinar here at ATS. Okay, how about suggestions if asphalt is transported over 100 miles? I would assume in regards to temperature, maintaining that temperature.
Steve, that one's yours.
Yeah, I think it can be done. I mean, as long as you don't lose temperature, that's the main thing. I've personally been involved with stuff that's or a hot mix that's been transported 80 plus miles, and fortunately it was in Florida. It was in the summertime, so it had a little better chance of holding its temperature. But it can be done. But the main thing is temperature. You want to be able to have a good temperature of the mix when it gets to the paving site so that you can achieve density, because that's what the bottom line is to achieve density.
You want to make sure your tarps, your trucks are really tarped, so there's no fanning of any air. Tarp on all four sides as it goes down the road, and on long hauls, I've noticed, well, they'll call the plant back and say there's a problem with the mix, there's chunks in the mix or whatever. And a lot of times the bottom of the truck will cool off between the axles en route. So the speed they run, making sure it's very, very tight, the tarp. And then there's also some additives that are available. Some of the additives, the anti-strip additives and the warm mix additives allow for a little bit more forgiveness in the field density, and material can be hauled a little bit further without a temperature drop, and it affects that density temperature curve. And that's another thing that could be explored, and there's quite a few additives that people promote and sell that that's one of their sales points. So it's something that you might want to look at if you're doing a long haul. I know some QC managers up north and in the Plain States and out west where they'll use those additives on cold when they're trying to extend their paving season. Early in the season or in the end, they won't use them during the middle of the season, but when they're on those long hauls, they'll employ those additives. So that's another thing you can explore.
Is there, I mean, I'm sure this is relative depending on where you are in the country, but is there a general rule of thumb, so to speak? You can expect to lose so many degrees of temperature every so many miles in the mix if you are not using any additives?
Well, climate plays a big point there. I mean, and Steve can address this too. So I don't think we can carte blanche, throw out a rule of thumb there. It's a heat loss game. So you've got mass, temperature, And if you're trying to pave in 35 degrees in Montana, which I've been a part of, and you're having to haul 50 or 60 miles, that's a whole lot different than paving in Mississippi.
I think you hit it right there. Yep. And your equipment of your trucks, like you say, a nice tight bed, tarp.
Okay, what is the best temperature with the super pave mix to bring on, wait, I'm sorry, I'm reading this incorrectly. What is the best temperature with the super pave mix to bring on the double drum roller, and the best temperature for the rubber tire roller?
Well, that's a trial and error, really, and it depends a lot on your mix as well. What kind of local, you have local sand in your mix, and your mix is a little more tender. You might want to let the temperature drop. Let's say if you behind the street, if you're getting 290 degrees, and you're getting on it with a double drum, and you're starting to push the mix or crack the mix, it's tender, then you want to back off and let it drop 10 degrees or 15, and then try it again. So it's a trial and error. Each mix is pretty particular about when you can get on it, and a lot has to do with the surface as well as the climate too. Ambient temperature outside, it's really, really hot, and the mix is staying hot, you might get some chatter in the mix, or some check cracking in the mix if it's too hot, or we have too much local sand in it. So it really depends, it's mix dependent, and it's a lot of trial and error.
Okay, TJ, what are your suggestions for success with baghouse controls when doing small quantities for a test strip, especially if you have to place at 2 asphalt contents?
Wow, will you read that again? Because they're throwing about 3 variables in there. I heard baghouse, short runs, test strip.
Okay, yep. So what are your suggestions for success with baghouse controls when you're doing small quantities for a test strip, especially if you have to place at 2 asphalt contents?
Well, wow. I'll tell you how I would manage that. If I was doing a test strip with 2 ACs, grades don't change, which means dust is not going to change. I would empty out all the dust return equipment. The thing about, well, here's what's hard. The baghouse is going to hold dust in the hopper. So your best bet is to, the day before you run this test strip, is to look inside the baghouse hopper. Every single baghouse has a hopper inspection door. Figure out what your dust level is in your screw, which is normal, okay? Prior to running your test strip, check that baghouse and make sure that has not changed. And then run at a steady run and make a mix change on the fly with test mix A and mix B, okay? And not stop, the operation. Prior to doing the test, you want to make sure that all your bags are cleaning. And the way you check that is you look in the hopper of the baghouse. If you see mounds of dust in the hoppers of the baghouse, discrete mounds, like one in the middle and one toward the back or one halfway down, then those bags are not cleaning right. So when you shut the plant off, that deposits extra dust in the mix and it'll fool you on a test strip. So make sure your baghouse is working right prior to the test strip. Make sure any bags that aren't cleaning are taken care of. Figure out what your hopper level is, and then prior to the test strip, evacuate all the dust out of your return equipment, but don't evacuate the dust out of the baghouse and run at a steady rate. Do not change the production rate. And I don't ever check the first 2 loads on a test strip. I lose them because you've got silo issues involved there and a lot of other things. So you want to make sure you make a good head of material. I don't like to be part of any test strip or any test run or any test mix that's done that isn't 80 to 100 tons. And I know Steve has got a lot of experience with different producers on this too. And Steve, you might throw in whatever I missed.
Yeah, I agree with you on that. I think it's a lot of reason why the FAA does their test strips are 250 tons. It gives you a chance to really run your plant, get it leveled out, and make a quality mix. I would say, yeah, 80 would be a minimum, preferably 100 to 200 tons on a test strip. And like TJ said, maybe lose that first load. If you got a lot riding on that test strip, that's cost of doing business.
I'd lose the first load if for appearance purposes, if anything, people are going to be crawling all over this test strip looking at it from stem to stern. There's a lot of states that make you throw away the first load of mix out of the silo and will not allow you to ship the last load at the end of the job of the run either. So it's fact, something to think about.
All right, let's move away from the plant for a minute, head back out to the roadway. Steve, is there an ideal paving speed, assuming that trucks are available?
An ideal paving speed. I've always said that, 35, 40 feet a minute, 50's pushing it. But, it depends on what you're placing as well. If you're placing like a 3/4 inch open graded friction course like we do here in Florida, then, 50, 55 feet a minute's fine. As long as you can keep the trucks, you want to keep up the pace, with the trucks that you have, so you can keep paving without stopping. That's the key. So, and in today's environment, the trucks are driving everything. I mean, trucks are hard to get these days. So, you really have to plan ahead. But yeah, an ideal to me, a nice dense graded mat, just looks beautiful, and it's great for me to get density on if I can keep you at 30, 35 feet a minute.
Okay. Heading back to the plant, any experience with warm mix? Does it provide any cost savings or durability versus hot mix?
I'll let Steve talk about durability, field density, and have his thoughts there. Basically, warm mix is going to save you 10 to 12%. Is generally the cost saving range on drying is anywhere from 10 to 15%, depending on which warm mix a procedure you use. Okay, so it's not an astronomical savings, but hey, 10% is a lot. There are some extra benefits on field workability with warm mix. So it's the energy savings from warm mix comes from reducing the temperature of the material that you're making. It's not the 20 to 30% that was touted years and years ago when it was new. People that track this data are looking at 12 to 15% numbers. I think there's a real benefit with field density, and there's some other benefits in the field, and maybe some forgiveness and time on paving, but I'd really prefer that Steve addresses that.
Yeah, there's benefits, especially on an additive warm mix. It gives you more forgiveness, allows more time to get compaction. Durability wise, from what I've seen, there's no durability. As long as you achieve density, target density, or, within a range of target density on the mixture, you're fine. The problem with warm mix here in Florida, we've had an issue with flipping our local cities and counties over to warm mix. I think the Florida DOT is all for it, and it's in their specification. You can do it anytime you want. It's getting our real good customers at the counties and cities, and our local contractors with our neighborhoods that want that nice, 320 degree mix, what they're used to, hot mix. So it's hard to flip back and forth during the day to make one hot and one warm. So
yep, that's a real production issue.
That's a production issue.
It's like switching mixes. You end up with two different temperatures. You may need two different silos, and it's just one more variable to try to manage. But Steve's hit the nail on the head. I mean, you can have success once you get your success figured out, but people develop habits and they just want to see the same thing all the time. And it gets to be, difficult making that happen in the real world.
Sure. What are your best practice? Oh, sorry. What is your best practice for cleaning milling dust off the milled surface?
Um, it's a combination. Tractor brooms work well if you're out in a rural environment. If you're in an urban environment, vacuum trucks. Um, if you got a real strong blower, like a little blower that you pull behind a trailer, maybe on a little John Deere or something like that, if you really get a wind force going and get that dust off, the real fine particles, that's your best option. However, if you're in an urban environment, you're downtown, people are going to get really upset if you're blowing a milled surface off with a blower and getting it all over the car dealers cars and all over the front of the buildings and everywhere like that, because that stuff goes everywhere. But yeah, brooms work great, but it just takes time. You just really got to spend the time to get it clean in the crevices where the joints are and all that. So, and the striations of the mill just needs to be clean.
Right. And once you have that clean surface, you can apply the tack like you were
Right.
talking about, one of the best practices. So how does the tack relate to density during the operation?
It's going to bond the lift that you're placing to the material that you're placing it on. So if you're placing a limestone, you need a good prime surface, and that's going to allow for some bond within the prime. If you're paving on a milled surface or an existing asphalt, that tack is going to bond those two layers together and keep it from sliding or shifting. It's going to lock it in. And that's what you need when you're achieving density. You don't want any unnecessary movement in the mat that you're trying to compact.
Steve, you mentioned roller heads. What exactly is that, or what do they look like?
Well, a roller head it's if you're rolling a mat and you're coming to change direction, so your roller is heading towards the paver, you want to turn the roller at an angle towards either the outside or the inside of the mat, and then stop the roller and then reverse direction. If you can come straight at the paver with the roller and then just stop and reverse, it's going to leave a bump in the mat that you're not going to be able to get out. Now, when you turn your angle at behind the paver, it's going to leave a knot in that mat as well, but that is going to be able to be rolled out. A straight on bump is not, but one at an angle will be. Why? I don't know. There's some little film clips out there that we use in some of our paving classes that show it with a rolling pin and Play-Doh, where they roll it straight in and then they can't get that knot back out of there. But if they come in at an angle and then roll it, you can get that knot back out. Why? I mean, it's a
Well,
I guess it just works. You gotta stop and reverse using that angle.
I seem to relate asphalt production a lot with a giant kitchen, TJ, as you know. So, Steve, now I'm thinking about rolling out dough for cookies,
There you
with the
go.
rolling pin. Although honestly, I don't bake, so I'm trying to conceptualize that. All right, one final question. We're coming up to the end of the hour here. Oh, we just had a comment. I can always tell the level of experience of my roller operators based on how they park the rollers. Excellent meeting. TJ, when you spoke of proactively calibrating or proactively checking the plant calibrations, how often should you do this?
The people who have, I didn't know this existed. This was not my idea. I discovered it. And I discovered it when I was interviewing a lot of people that were having problems and people that were not having problems, people having success over years. And it's like, the answer is the people who do this do it every 2 to 4 weeks. So it's kind of like once a month, whether you need to or not. But a lot of guys are on this every couple of weeks or so, and they're just checking things and making sure they haven't changed. Remember, it doesn't take very long to check any individual calibration point, right? And if they got time, the guys that really have got craftsmanship in their brain, in their veins, in their brains and their veins, they just kind of do that on their own. And that was a nice discovery I made years ago. And so, hey, it's kind of like, short answer, I'm burning up time, but I mean, if you want to learn from a good golfer and you find out that he always plays 2 or 3 practice rounds before he plays the tournament, then you say to yourself, maybe I should do the same. It's learning from people that have great success. So hope that answers it.
Awesome. Well, thank you both. I know you both have had great success in this industry. So thank you for your time today and presenting the habits that you've learned over the years to all of us in attendance. Thank you all for attending wherever you are tuning in from today. And a recording of this webinar will be made available if you need to go back and review anything or share it with any of your colleagues. And you can check our website for any future upcoming webinars. Our next one will depart towards the end of September, I believe. I don't have my itinerary in front of me right now, but thank you all again, and we will see you soon. Thanks, Steve. Thanks, TJ.
Thanks,
Thanks,
Mom.
guys. Thanks for
Bye.
tuning in.